Have you ever stopped to think about what would happen to your body if you spent years floating in space? And what if I told you there are planets where, while you'd spend just a few minutes, entire decades would pass on Earth? Or even, have you imagined being trapped in a world where gravity is so weak that your own body couldn't move? Space is not just a place of wonders and discoveries. It can also be the perfect setting to accelerate aging, deform your body, and even tamper with your DNA. Space may seem fascinating, but it's ruthless to the human body. Today, we'll explore how spending years in space can accelerate aging, alter our physiology, and even shape the future of humanity. Get ready for a journey that will spark your curiosity and change the way you see the universe and our existence within it. However, to understand the effects of spending years in space, we first need to grasp how our bodies function on Earth. Here, gravity is a constant force, shaping everything around us. From how our bones strengthen to how blood circulates in the body. But in space, this force disappears. Suddenly, everything we take for granted, walking, eating, or even sleeping, becomes an extremely difficult challenge. Imagine floating in zero gravity, without the pressure that strengthens your muscles and bones. First, it might seem fun, but over time, weightlessness starts to take its toll. Without gravity putting pressure on bones, they lose density, a phenomenon known as bone demineralization. It's like living with accelerated osteoporosis, and that's just the beginning. Another critical factor is cosmic radiation. On Earth, our atmosphere and the planet's magnetic field protect us from most harmful radiation. In space, however, we're exposed to high-energy particles that pass through the body, damaging cells and even DNA. This extreme environment pushes the limits of human survival. These are just glimpses of the challenges we face in space. What seems like an incredible adventure is actually a constant battle against a hostile environment. Without the gravitational force we're used to on Earth, our entire musculoskeletal system begins to adapt, or rather, to weaken. In weightlessness, muscles lose the need to support the body, leading to rapid muscle atrophy. It's like spending months bedridden without moving. Bones, in turn, undergo demineralization, losing about 1% of bone density per month. For comparison, this equals a decade of aging in just 1 year. Without gravity, blood is no longer pulled to the extremities of the body, causing a redistribution of fluids. This phenomenon results in what many astronauts call puffy face, where fluids accumulate in the upper body. The heart, which doesn't need to work as hard to pump blood, also undergoes changes. It may become rounder and lose some of its efficiency over time. The absence of gravity also impacts the nervous system. The redistribution of fluids increases intracranial pressure, which can permanently affect vision. Additionally, the lack of earthly sensory stimuli, such as natural sounds and vibrations, can alter brain function. Real cases, the Kelly twins study. One of the most fascinating studies on the impacts of space on the human body is the case of twins Scott and Mark Kelly, both astronauts. While Scott spent a year aboard the International Space Station, Mark remained on Earth. Researchers observed significant changes in Scott's body. DNA alterations, loss of bone and muscle mass, and even shortening of his telomeres, structures directly linked to cellular aging. These changes are a clear reminder that the human body was not designed to live outside Earth. But can space really accelerate time for those living in it? In space, we are completely exposed to cosmic radiation. These high-energy particles pass through the human body, causing significant cellular damage. Unlike ultraviolet rays on Earth, which mainly affect the skin, cosmic radiation penetrates deeply, reaching internal tissues and even DNA. This leads to genetic mutations that can result in premature aging, increased cancer risk, and other health issues. A practical example is the shortening of telomeres, the ends of chromosomes that protect our genetic material. Shorter telomeres are directly linked to cellular aging. During the study of the Kelly twins, scientists observed that while Scott was in space, his telomeres shortened significantly, indicating that he was aging more rapidly than his twin brother on Earth. Thus, in space, the body is constantly in a state of accelerated deterioration. In addition to cellular damage, Astronauts report visible changes after long missions. Wrinkles, sagging skin, and even alterations in facial structure can be noticed. This happens because the lack of gravity affects the distribution of fluids in the body, while radiation impacts the skin's elasticity. But what about the relativity of time? While space can accelerate biological aging due to extreme conditions, time itself can flow differently depending on speed and location in the universe. If we are near massive celestial bodies such as black holes, time may slow down relative to Earth, but during interplanetary travel, where we are far from these gravitational forces, biological effects tend to dominate. And if living in space already presents immense challenges, imagine what life would be like on other planets or moons in the solar system. Mars, the nearest destination for future manned missions, presents significant challenges. With only 38% of Earth's gravity, adaptation would be inevitable. Low gravity would further affect bones and muscles, exacerbating the bone demineralization and muscle atrophy already experienced in zero gravity. Additionally, Mars's atmosphere is composed almost entirely of carbon dioxide, making the constant use of pressurized suits or habitats essential. Another concerning factor is radiation. Mars lacks a significant magnetic field or a dense atmosphere to protect its inhabitants, exposing settlers to much higher doses of radiation than on Earth. This increases the risk of cancer and accelerates cellular aging, making radiation protection a top priority for any mission to the Red Planet. Moons like Europa, orbiting Jupiter, and Titan, orbiting Saturn, are also considered for future exploration. Titan, with its dense atmosphere and lakes of liquid methane, offers a completely intriguing scenario. Titan's gravity is even lower than Mars's, and the temperature is so low that any exposure to the external environment would instantly freeze a human. However, its nitrogen-rich atmosphere and moderate pressure make it one of the easiest places to adapt for eventual habitation. Over generations, humans living off Earth may become a species adapted to space conditions. Life in space and on other planets would not only impact individuals but could transform the human species itself over time. Exposed to extreme environments and different gravitational forces, humans would undergo an evolution driven by external conditions and technological advancements. Imagine generations living on Mars or in space stations. Reduced gravity could lead to thinner bones and less robust musculature, as the body wouldn't need the strength required to resist Earth's gravity. Humans on Mars, for example, might develop taller and leaner bodies, while in environments with higher gravity, bodies could become denser and more compact. Eyes might also change, adapting to lower light levels in enclosed environments, or intense ultraviolet radiation on planetary surfaces. Even human skin could evolve, producing more melanin or developing other mechanisms to withstand cosmic radiation. The cultural and physiological differences between groups living on Earth, Mars, or space stations could become so significant that, over time, entirely distinct identities might emerge. A true cultural and even social diversification of humanity, whether through natural evolution or technological intervention. Future humans could become unrecognizable to us. A new hybrid species, Homo galacticus, perhaps might emerge, shaped by forces we can't even imagine today. These transformations raise profound questions. How far are we willing to change to conquer the cosmos? And as we adapt, will we still be human as we recognize ourselves now? With advances in technologies like CRISPR, it might be possible to modify human DNA to adapt individuals to environments with low gravity or high radiation. But how far should we go in modifying our biology? Furthermore, who decides what should be modified and why? One of the promises of biotechnology is the potential to slow aging and even reverse some of its effects. If humans were to adapt to live for hundreds or thousands of years in space environments, it would raise questions about the limits of immortality. Additionally, with the possibility of living longer, concerns about managing resources in limited environments would arise. No planet has enough resources to support an immortal humanity. Would this mean colonizing other planets in search of resources? What do you think about space travel? How do you imagine our species evolving over time, living away from Earth? Share your thoughts in the comments. Another profound aspect is the impact of space life on our identity. What does it mean to be human when our bodies and minds are altered by technology or adapted to new planetary conditions? As we move farther away from Earth and become beings designed to live in space, will we still be the same humans we are today? Or will we become what we have long feared? What does it mean to be human when we no longer have the cultural, natural, and social references that have defined our history? Will we become something new, a new form of life, or will we still preserve the essence of humanity, no matter where we are in the universe? As we adapt to new environments, it will also be necessary to discuss the rights of space humans. Who would have the right to inhabit other planets? Earth, with its limitations and resources, may just be a starting point. But as new colonies are established, questions about governance, sovereignty, and justice will become even more complex. If a person were born on Mars, for example, would they be considered a citizen of Earth or have their own rights, belonging to a new space nationality? Space exploration will not only affect the individuals directly involved, but will have a profound impact on future generations. Imagining what would happen if a human spent years exploring unknown planets. The possibilities become endless. Each planet or space environment would have its own unique conditions, and the human body's reactions to these places could be surprising, challenging, and even frightening. Imagine a planet completely covered by deep and vast oceans, with no land in sight. In such an environment, humans would face not only the absence of terrestrial resources, but also the constant adaptation to an aquatic environment. The planet's gravity could be stronger or weaker than Earth's, affecting the body's physiology in dramatic ways. On a high-gravity planet, human muscles and bones would be overburdened. Constant exposure to water would also bring challenges to the immune system. The lack of exposure to Earth pathogens could result in lower immunity, making astronauts more susceptible to new alien diseases. The emotional impact would also be severe. Isolation on a planet with no visible horizons and constant immersion in water could lead to hallucinations, post-traumatic stress, and depression. On the other hand, a planet without water, only desert, presents a radically opposite scenario. Gravity could be similar to Earth's, but the lack of essential resources for human survival would require drastic adaptations. The human skin would be one of the first organs to suffer. Cosmic radiation would hit the body without Earth's atmospheric protection, increasing the risk of sunburn and skin cancer. The scarce and dry air would lead to dehydration. Bone health would also be affected. The lack of water and constant sun exposure could dehydrate bones, making them brittle. Breathing would be more difficult in a desert environment. On a high-gravity planet, humans would face constant weight overload. This would make every movement more tiring, and the joints and muscles would suffer enormously. The additional pressure on internal organs could harm the cardiovascular system, making it harder to pump blood throughout the body. Blood circulation would become a challenge, with blood pooling in the lower extremities, potentially leading to thrombosis or other circulatory problems. High gravity would also impact bone structure. The human skeleton, designed to withstand Earth's gravity, could begin to break down under excessive weight. The body would have to adapt, but this would take time and likely cause irreversible problems, making humans increasingly dependent on technological supports to move or even breathe. On a low-gravity planet, the changes would be equally drastic, but in the opposite direction. The human body, accustomed to a normal gravity environment, would begin to undergo a series of adaptations. In the long term, the lack of gravitational resistance could even affect the cardiovascular system, as the heart would need to work differently to pump blood. Regardless of the planet, time would also play an important role in adapting the human body to the environment. Gravity, temperature, radiation exposure, and available resources would affect the body's biology in ways we cannot fully predict. The longer a human spent on one of these planets, the deeper the physical and psychological changes would be. Loneliness and isolation would also be critical factors. Sensory deprivation, the distance from home, and the lack of contact with other humans could drastically affect mental health. If humans survived physically, it would be the psyche that might succumb first. Adaptation over time would be possible, but how space environments would shape our biology and psyche is still a mystery that only the future can answer. With future manned space missions and even prospects for colonizing distant planets, profound ethical questions arise. Would it be morally acceptable to send people to extremely hostile and isolated environments, knowing the risks and harmful effects on human health, such as cosmic radiation and muscle loss, in a scenario where survival would be difficult? What would be the responsibility to protect astronauts? Additionally, there is the dilemma of exploring other planets and celestial bodies. If humanity establishes itself on Mars, for example, or on some other exoplanet, how will we deal with the potential contamination of these unknown ecosystems? And if there is some form of extraterrestrial life on these planets, what will our responsibility be toward it? The questions surrounding the preservation of natural environments and the ethics of exploring these places will become increasingly urgent as space missions progress. As space exploration advances, humanity faces complex issues, unprecedented challenges, and incredible opportunities. What we are beginning to understand is that the journey into space is not just about conquering new worlds, but about transforming the very nature of humanity. The implications of spending years in space go far beyond missions, physics, and the technologies developed. They touch the depths of our identity, our survival, and even our morality as a species. By sending humans for long periods away from Earth, facing the loneliness of deep space, disconnection from our planet, and the vast expanse of the cosmos, we are forced to rethink our own existence. Every space mission serves as a reminder that despite the difficulties, humanity has the ability to adapt, overcome challenges, and explore the unknown. Space exploration is not just a physical journey, but a spiritual and intellectual one. It teaches us to respect the Earth, to value our science, and to marvel at the vastness of the universe. In doing so, it leads us into a new era of understanding of ourselves, the planet we live on, and our place in the cosmos. Looking to the future, we can conclude that space travel will not only take us far from Earth, but also help us better understand who we are, where we come from, and where we are going. And that is one of the greatest journeys any species can undertake. What do you think about this immense journey of discoveries and challenges that await us in space? How do you believe humanity will be impacted by long space journeys, whether in terms of technology, health, or even our vision of the future? Are we ready for the transformations this may cause in our society and our own identity as a species? Did you enjoy the video? Then don't forget to like it if you want more content about the wonders of the cosmos and the curiosities of the universe. And of course, if you haven't subscribed to the channel yet, make sure to subscribe now and activate the notification bell so you don't miss any new videos. We have much more to explore together, and we want to hear your opinion on upcoming topics. After all, space is infinite, and the possibilities for what we can learn and discover will never end. See you in the next video.